Ahoy! My name is Mr. Warden. I am a physicist, I am a maker, I am an educator, and what you're about to see is a culmination of my life's work. Everything I own is in this room. I have no money. I've unplugged my computer. I've disconnected my phone. I've divested myself of all unnecessary attachments in order to do what you're about to see. What you're about to see is called Living a Curious Life. It is a pedagogy that demonstrates a reverence for the emotions that we feel and how those feelings become knowledge. Living a curious life simply means that we let our feelings guide our actions, and vice versa. In other words, the things I believe are the things that I'm doing, and in so doing, I am fully alive. And I ask that you join me, or at least, keep an eye on me. Welcome to the show, JDs and Welcome to the show, JDs and Littleman. So you're joining us right in the middle of things. This is me editing the video you just saw a second ago. We have three primary well springs of resources that we can turn to in times of need. The first is within us, right? Human capacity for stuff. Human powers. Our resources, which are all the things that we have here in the shop, and the people around us. Now, I don't have a lot of interpersonal relationships, but that's something that we're going to work on, I guess? No? I don't know. Of primary importance to our goal is to maintain homeostasis. As a human being, I do have to maintain a certain mass. I do have to eat food and drink water and meet other human needs like having sleep, etc. For the record, here is the state of our food stores. Right now, we don't have a ton, but we have enough to keep us from starving to death. In the food box, we have about 22,000 calories worth of good stuff. We also have several pounds of flour, several pounds of salt, several pounds of macaroni and cheese. That will become relevant here shortly. We also have a number of frozen foods that will keep us going even beyond that. So we have at least 9 days worth of food, and probably more, because we can make it stretch, because we got a lot of reserves. Play it all night long. Oh, heaven. Heaven is a place where nothing ever happens. Okay, let's fix the air fryer. Alright, so the problem with the air fryer is that it does not turn on. When I plug it in, nothing occurs. Nothing happens. So that's a problem, especially for somebody like us who needs to eat food. See, there's something rolling around here in the bottom, or on the top. We have no choice but to continue to investigate, so that's what we will do. Boy, they really don't want you to get into this thing, do they? My hope is that there's something very obvious rattling around here that we can easily put back together. There was a key inside. This is the mail key from the house we moved out of. This was in there. It must have fallen in there somehow. Rattling around in there, shorted something out, broke something. I suspect that was what was wrong with it. There we go. Okay. Now we're talking. Get some light in there. Okay, now, okay. Okay, that's a lot. That's a lot. That's a lot of info. There we go. Okay. Let us first determine whether or not and at what capacity this control board works, because this was not even turning on, and if this is not even turning on, that's kind of a problem. I'm inspecting the board for anything obviously wrong. Let's check some continuity. I have my little continuity testing device that I built. All this is that when the two leads are in continuity, the light comes on. Yes? Okay. I can't tell by looking at it what the pins are, but we can kind of do some... Whoa, okay. I'm managing to turn it on. Okay, great. I managed by accident to find the power, power input. Great. That's good. That's good news. Means, but that tells me that the board's not, there's nothing wrong with the board. It was just something, maybe there's something wrong with the cable. There we go. Okay. And then that's on. Okay, great. So what I've just learned through experimentation is that our Z pin is the on switch. If that makes sense. And when we plug it in, that should happen. When we plug it in, everything should light up, and then it should come up with one thing that says time to turn on. So it should go into a standby mode where everything lights up. And whenever we put a signal, that's what we get. So let me just do it like this so you can see it once more. So what happened? So what happened to it? If nothing happened with the logic, run rabbit, run rabbit. So we're gonna have to start putting things back together once we know that each part works. So we know there's nothing wrong specifically with this LED board. It is working. What the problem is now is the electricity is not going to the right place. Something's happening between the plug and the board. I bet we need to take out the power board. Okay. Well, it's obviously not getting the right amount of voltage, and that's why it's probably not doing anything else, but it tells me that the problem's in the power board. And I didn't want to take it apart anymore. Okay. Okay. Rabbit. Yeah, just gonna take everything out. So there are switches on each corner of this that make sure that it can't turn on unless it's shut. Hold on. That was it. Okay. Now we gotta put everything back together. Rats. Alright, I won't make you watch that part. Alright, I managed to get the entire top boat back together, which is very nice. I'm very happy with that. And now it's time to get all the bottom back together. This thing turns on when we actuate it, but whenever we put all the stuff back together, it stopped working. And even when I plug the board in just to this and try to plug it in, nothing happens. And we are going to have to retake it apart, or at least retake the top apart, not the bottom. Alright, now with the top off. Alrighty, made some progress. Not an electricity problem. I didn't even check the first connection, only to figure out that one of these switches is broken. Remember? We just did this a second ago. Right? This switch is not actuating the way it's supposed to whenever this is closed, right? So whenever I open the air fryer, you can see that switch actuating. And when I open this side, you can see that switch is not actuating. So let's figure that out. Please, 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 whatever you're doing, don't try this at home. Especially don't try to put things together while having them plugged in, which I've done before. As always, I encourage you not to do exactly what I do. I encourage you to learn. I encourage you to, if you are under 18, I encourage you to work with adult supervision. And if you are over 18, be careful. Ask for help. Ask me for help. I'm here. That's what Mr. Warden's Workshop is about. We're here to ask each other questions. So if you have a question or you're like, Mr. Warden, this seems dangerous, leave me a comment. I got you. I got you. I'll walk you through what's going on. Alrighty, I've found the problem. This drawer has a piece of plastic that actuates, I'll point to it in the edit, that actuates the switch that we're trying to find. This drawer that's not working is broken right there. That's what we have to fix. So the actual like metal cooking bucket in here is rotten with these little metal tabs that made it. It took me like 25 minutes to get the bottom back together, but it's together. And everything still works as intended. When we actuate the two switches that we suspect is the problem, it turns on normal enter standby mode, by the way, so we can then subsequently turn it on. Now I'm going to put we still have to fix the drawer to make sure that it does this whenever I'm not sitting here holding it, but progress. So let's get right in here real quick and I'll show you exactly what the problem is. Here is the drawer that goes in the air fryer. And right here where my thumb is, it's black, so it's difficult to tell. There's a piece of plastic, and that plastic is curved, and what it does is it presses a switch whenever it goes inside, and that switch cannot be pressed because the piece of plastic has broken. Now, I found what I believe I'm going to use to try to fix it. This is a little plastic divider from one of these drawers, or a drawer like this, and I'm going to cut out a chunk from the top and see if we can't glue it in place and see if that won't work. So let's see. If you're wondering what I used to cut that, I have a chisel right here that just chewed through that. We'll slice through it, you know what I mean. There's no way you're going to be able to see this, so you're going to have to take my word for it. It fits pretty well. That's the shape. That is the shape. That's the shape of the piece that's missing that we're going to glue back into place. Right there is broken. Something like that. And I'm going to glue that into place. Looks pretty good, right? We may have to take a couple passes at this, because this is going to be a tight little move. Don't worry, we're going to clean this very thoroughly before we try to do anything with it. So don't be alarmed. Here's what it should look like. There's my replacement. Needs to be clean, but we're working on it. Alright, this is not going all the way in there because there's super glue around the bottom, and so let's clean it up. Hopefully we don't break it this time. I'm going to get a smaller chisel. Please make sure to chisel away from yourself at all times. I've had a number of chisel accidents in my life. Anyway, I know it can be inconvenient to try to reorient yourself every time you go to make a cut, but it's really important. Basically, you have to think about every time, like, if this slips, will it hurt me? Oh, is it too long? Where's my calipers? Dial calipers. It will allow us to precisely measure the length so I can match this one accordingly. So from the base to the tip, let's see. Well, actually, it's probably going to be best to measure from the curve. So let's do something like that. The one that is intact has a measurement of 0.811. Let's double check. Yep, 0.811. And this one is, and mine is way too long. I didn't even realize how long it was. Okay. Let's make a mark. Okay, so this is what it should sound like when it goes in. Not quite. Hey. Bam. I'm not saying it's perfect, but it gets the job done. It has some adjustments to be made. Let's make some fine adjustments now. Again, the super glue has made it so there is extra material. We wanted extra material because we needed that dimensionality. But too much is interfacing with the mechanisms now. All right, that's in there. Heck yeah, good job everybody, we made it. Hicimos, we did it. Let's get in here. Let's see it. Let's see up close. All right, there's the normal one. That's the piece in question right here. Here's mine. It's not pretty, but it just looks that way because it's white on black, but you know, shows white. But boom. Victory screech. See if everything turns on. That's what it's supposed to do. Splendid. Okay, now we got to put the top back together, and then we'll be ready to eat. Well, we'll be ready to try to cook something, which should be interesting, and may not work at all, but such is the nature of experimentation. This is the fan motor that turns the blower on that allows the air to circulate, so very important for an oven. I believe we have an air fryer. These motor windings are hot, which tells me it's getting power, but it's not doing anything because something is stuck. Yeah, definitely a motor issue, right? Because it's really hot. Like, it should have turned on before now, so at least we got that out of the way. There's your problem. Why don't you try to hear this? Hear how much resistance is in this fan? Part of that might have to do with this that I have left off. I assume that's what it is. This is just an offset. It's just a spacer that is flattened on one side for the motor shaft, and it's going to keep it spaced away from what it's rubbing against to hopefully not rub anymore. Which means the electricity can go where it needs to go, which is turning the fan, so the fan comes on. See, now we're happy I didn't put all the screws back in. Alright, if I was going to characterize what's actually happening, that nut right there, I don't know if you can see that, but there in the heating element, there's a nut, right? And that's holding the fan in place, but it's not in the right position because the standoff's not included. So we got to get the standoff in there, which means we got to take this apart, which means I kind of want to remove the heating element again, which is probably what I'm going to do. It's also very possible we're going to have to go get some thermally conductive paste to reinstall the heating sensor, or the temperature sensor, because I suspect that might end up being a problem. Let's see if the motor turns on like this. Yes, it does. All right, how do we feel about that? This is a reverse threaded nut, so it's lefty-tighty. Righty-loosey. Bam. The reason that it's a reverse threaded washer is because the fan is spinning in the same direction that you would use to unscrew it, and so if it's spinning like that, as it vibrates, it's going to unscrew itself, and so this way, as it turns on and as it works, it's going to tighten it, which is really ideal. Let's cool that down. Sorry, things got a little complex in there with the hands, and so I had to turn the camera off. But everything is looking pretty good. All of my rubber washers are back in place. My metal washers are now going to be in place, and we're going to put some screws in. And then we can cook something, and then we'll be able to eat, because we need to eat, because we're human. Let's do a fan test. One last thing we need to do that we can do while we're trying to fix the fan, because I think it's just not tight enough, basically. This is an extreme heat epoxy. This is an adhesive, and we're basically going to use this to seal the temperature sensor back on. Now, I'm not saying that you should consume anything that comes out of this after we do this repair, but this is how we're going to fix this. We really just need like not even that much. That's probably too much. Very much like our super glue, I'm going to utilize this epoxy to build kind of a dimensionality. I want to make sure it's sealed. I just got to put something heavy on it, and then we have to let it sit. I am not saying that you should eat anything that comes out of here. Do not try that at home. Please let the record note that I bought this with a gift card that I got for Christmas, which was, it's currently January 6th, I think. That's where this came from. We will use it sparingly and use it only when needed. This is probably the only container we'll ever need for the rest of our life, unless we have a big job. Alright, I'm going to leave that chisel on there, wait for this to dry. It's going to take 24 hours, so I guess I'll see you in 24 hours. Okay, here we are. The temperature sensor, as you can see there, the glue has cured. Everything looks pretty good. It looks sealed. I don't see any air gaps. And it's on there. If you're wondering, this is the temperature sensor, right? It's on there. Meanwhile, the fan I was able to also fix because there was just one little fan blade on this fan that was a little bit bent and it was rubbing, and so I managed to unbend that and unrub it. I believe, if we're not mistaken, we're ready to cook something. Okay, let's cook something. It's hot. So we have a corn dog. Everybody out there, please make sure that you subscribe to see what we do next. Please like so the algorithm picks us up, and leave a comment so you can ask me questions and you can figure out what we're gonna do next.
A successful repair, indeed.